Okay, now we're going to write some code for the template design pattern to indicate how it works. And this is going to be a robot template, a abstract class, so it has to be inherited before you can actually use it. This is a robot template class, and it's got a template method. In this case, that template method is called go. It'll call these actions, these methods in sequence: start, get parts, assemble, test, and stop. And this template method is going to be appropriate for working with all kinds of robots. For example, as we said, automotive robots that build cars, or cookie robots that bake cookies, and they all rely on this sequence of actions, and so it's appropriate to have a template that can be called and will execute those sequence of actions in sequence like that. So that's the robots template. You can also create default versions of these actions in the templates. Start, for example, prints starting, get parts, prints getting parts, and so forth. Assemble, prints assembling, test, prints testing, stop, prints stopping, and those are useful in case the inheriting class doesn't actually implement one of those methods. For example, if it doesn't implement the test method, then you're going to fall back on working with using the test method in the template, which is going to print out testing like that. Okay, so now we're going to create an automotive robot. It extends the robot's template class, and so it already inherits the go method. Now, all you're going to have to do in the automotive robot class is to override those methods that you want to override. For example, getting parts is getting a carburetor. Assemble, installing the carburetor. So this is the specific job that the automotive robot has to do. Test is revving the engine, for example, like that, as you see. So that is the way that the template pattern is implemented. You have a template, you inherit a class from it, you extend the template class into a new class, and then override those methods you want to override, so that when they're called, when the template method is called, they'll be called in sequence. Those methods will be called in sequence like that. Okay, so much for the automotive robot. Also in the automotive robot, you can add your own class, your own methods as well. You're not stuck to just implementing those ones that are in the template method. You can also implement your own methods. For example, getName returns the name of the robot, and it's not part of the template, but it is an additional method you can implement if you want. Here is the cookie robot. It also extends the robot template, and however, getting parts will be different for the cookie robot than from the automotive robot. Getting flour and sugar is the get parts message, and it prints out that message. And assemble is baking a cookie, and test says crunching a cookie, for example. So the idea is that although the sequence of actions is the same and is defined in the template, when you actually inherit, and you can customize what's actually going on in those actions by overriding those methods. For example, get parts before was getting a carburetor for the automotive robot, now it's getting flour and sugar. Okay, so crunching a cookie is what the test method prints out. So as you see, the idea is, although the sequence of actions is the same, and that's defined in the template method, the way what those methods actually do is defined by the inheriting classes. So it's going to be different from an automotive robot than from a cookie baking robot. So next we'll put these two robots to work to see whether or not they have in fact been constructed correctly, and we're going to run their template methods so they will perform their actions in sequence, and we'll check to see whether or not their actions have been customized appropriately, as is customary with the template design pattern.